Hello friends, now this is the last part of the miscellaneous exercise 2a and this is the end of this matrices chapter. In this chapter I had covered all videos. I had covered all the exercise and miscellaneous 2a and 2b. Now from the next video I will start the new chapter, that is a trigonometry. Okay. At the same time I am teaching on an academy platform for M1 and M2 for the 12th standard, also teaching for the MST CET examination preparation. And if you like all my videos from the an academy, then you can take its subscription, and if you apply my code, that is the Vasant sir, you will get discount for that subscription. And after this small video you can see some PowerPoint slides from an academy. At the same time, in the description box there is some links of an academy. You can see that free lectures of my Mathematics M1 and M2. An academy plus subscription, master batch for MST CET 2021. Learn from top educator of MST CET for the preparation. Okay. In-depth analysis of the topics. प्रत्येक टॉपिक्स हे डिटेल मध्ये तुम्हाला शिकवलं जाईल. Dedicated doubt clearing session, and these batches are starting from the 4th of January. You can enroll now. आणि तुम्हाला जर त्याचं सबस्क्रिप्शन हवं असेल, त्यामध्ये डिस्काउंट हवा असेल, तर इथे माझा प्रोमो कोड वापरा तुम्ही तो, दॅट इज वसंत सर म्हणून हा. नेक्स्ट, जर these are the benefits for the plus subscription, that is everything under single plus subscription. Next, the best plan for MST CET 2021 aspirant for the 12 month, for the 6 month. Okay, new batches starts every Monday. Okay, you can use this promo code. Again, these are the top educators. सर्व तुम्हाला डिटेल मध्ये शिकवलं जाईल. त्यामध्ये बोर्डाच्या एक्झामची प्रॅक्टिस, त्याचबरोबर सीईटीची देखील प्रॅक्टिस केली जाईल. नेक्स्ट इज टेस्ट series is also there, an academic test series. Next, how to attempt the test series आहे इथे दिलेलं आहे. आणि हा जर तुम्ही प्रोमो कोड माझा वापरला तर निश्चितच तुम्हाला त्यामध्ये डिस्काउंट मिळेल. डिस्क्रिप्शन बॉक्स मध्ये देखील लिंक दिली आहे अनअकॅडमीच्या फ्री क्लासेसच्या. निश्चितच तुम्ही ती लिंक बघा आणि त्यावरचे माझे व्हिडिओ बघा. निश्चितच तुम्हाला परीक्षेसाठी, 12वीच्या बोर्डाच्या परीक्षेसाठी आणि त्याचबरोबर MST CET साठी देखील तुम्हाला त्याचा फायदा होईल. Now find the inverse of A matrix 1 0 1 0 2 3 1 2 1 by elementary column transformation. Okay, therefore now we'll first find out the determinant of the matrix. There is a 1 0 1 0 2 3 1 2 1. Okay, now it's a determinant 1 into, delete the corresponding element column and the row, and the 2 into 1 2 minus 6. Next is a 0 1 in bracket 0 minus 2, and therefore you will get here minus 4 and minus 2, that is equals to minus 6, which is not equals to 0. Therefore A inverse exists. A inverse exists. Now consider consider, here is A inverse into A, that is equals to I. Because here we are considering the column transformation, therefore here is A inverse, and then in bracket you will get 1 0 1 0 2 3 1 2 1 is equals to the identity matrix 1 0 1 0 0. Next is 0 1 0 0 0 1. Okay. Now by the operation, here already 1, then here is also 0, make this as a 0. Therefore, by the column transformation, C3 minus C1, we get C3 minus C1, we get A inverse into, here is a 1 0 1. Next is a 0 2 2. C3 minus C1, there will be 0. Next is a 3 0 is equals to the first two column as it is. Next is a 0 1 0 0 0 1. Sorry, here is a C3 minus C1, therefore here is a we'll change it, C3 minus C1 is a minus 1, okay, 0 and 1. The next operation is by C 2 3, we get C 2 3, we get here A inverse. The first column is as it is 1 0 1 0 3 0, okay, and the last column is 0 2 2, okay, and that is equals to here 1 0 0. Next is minus 1 0 1 0 1 0, okay, here is a here now. Next, by the operation C2 minus C3, therefore here you will get the first column is as it is 1 0 1. Next is C2 minus C3, here is a 0 1 and minus 2 0 2 2 is equals to C2 minus C3 1 0 0 C2 minus C3, and here you will get minus 1, again minus 1 and 1 0 1 0, okay, here is a minus 1 1 0 1 0, and what about here, it's a 0 1 minus 2 2 2. Now the next operation is a make this element as a 0 by the operation C3 minus 2 times C2. Therefore, here you will get the first two column as it is 1 0 1. Next is 0 1 minus 2 Okay, and here is a 0, 0, 2 minus in bracket minus 2, that is a 4, and overall you will get here 6, that is equals to here the first 1, 0, 0, next is a minus 1, and 1, C3 minus 2 times C2. Therefore, here you will get only 2. Next is 1, and that minus and minus will become 3, and last is C3 minus 2 times. Here is a minus 2. Okay. Now the next operation is a, first of all, make this element as a 1 by 1 upon 6 C3 we get, okay, the A inverse. The first is 1, 0, 1, 0, 1, minus 2, 0, 0, 1 is equals to 1, 0, 0, minus 1, 1, 2 upon 6 means what? 1 by 3. 3 upon 6 means what? 1 upon 2. And last is minus 1 upon 3. Okay. Now here is a 1. Next is by the operation. By the operation, that is a C1 minus C2 and C2 plus 2 times, sorry, C1 minus, here is a C3, C1 minus C3 and C2 plus 2 times C3. Therefore, here you will get the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the identity. On this side, C1 minus C3. This is C1 minus C3. 1 minus 1 by 3. There is a 2 by 3. Next is a 0 minus 1 upon 2. That is a minus 1 upon 2. 0 minus in bracket minus 1 by 3. There is a plus 1 upon 3. Next is C2 plus 2 times C3. This is C2 plus 2 times C3 minus 1 minus 2 by 3. That is a minus 3 plus 2. And overall you will get minus 1 upon 3. Minus 1 upon 3. Next is C2 plus 2 times C3. It is a minus 1 and 2 will get cancelled, and overall here you will get 0. Last is C2 plus 2 times C3, that is 1 minus, again here is minus 1 upon, that is 1 by 3 only. Okay, here is a 1 by 3, and last column is as it is 1 by 3, 1 upon 2 and minus 1 upon 3. And in this way we can take again the common. Therefore, A inverse is equals to take 1 by 6 as a common, because it is a LCM of 2 and 3. 1 by 6. That's why here you will get 2 into 2, that is a 4. First element is a 4. Next is a again minus 2, 2. Next is a minus 3, 0, 3, 2, 2 and minus 2. This is the A inverse. Find the inverse of 1, 2, 3, 1, 1, 5, 2, 4, 7 by row transformation. Okay. Let A is equals to, we will find out the determinant of this matrix first of all. 1, 2, 3, 1, 1, 5, 2, 4, 7. Okay. Now next is, therefore the determinant of A is equals to 1, 2, 3, 1, 1, 5, 2, 4, 7. Okay, this is 1 into 7, 5 into 4, 20, minus 2 in bracket 7 minus 10 plus 3, 4 minus 2. That is there is a minus 13, and minus 3 minus 2 plus 6, 4 minus 2, 2, and then you will get here 6, and overall that is a minus 1, which is not equals to 0. Therefore determinant is not equals to 0, and hence A inverse exists. Therefore A inverse exists. Now consider A into A inverse, that is equals to R. Now what is A here? A is 1, 2, 3, 1, 1, 5, 2, 4, 7, and into A inverse, that is equals to the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now by the row transformation, by R2 minus R1 and R3 minus 2 times R1. Therefore here you will get, the first is 1, 2, 3 is a 0. Next is R2 minus R1, here is a minus 1. Next is 5 minus 3, you will get 2. And last is, it is a 0, 4 minus 4, 0. Next is a 7 minus 6, 1. Okay, into A inverse, and here is a, the first row is as it is 1, 0, 0. R2 minus R1, here is a minus 1, 1, 0. Next is R3 minus 2 times, here is a minus 2, 0, and 1. Okay. Now make this element as a R2 minus 1 as a plus 1. Therefore by minus 1 R2 we get, there is a 1, 2, 3, 0, 1, minus 2, 0, 0, 1. Okay, here is a inverse, and on this side 1, 0, 0, 1, minus 1, 0. Next is minus 2, 0, 1. Now by the operation, which is the operation by R1 minus 2 times R2. R1 minus 2 times R2, we get, okay, there is a 1, 0. That is R1 means what? 3 plus 4. 3 plus 4, that is a, here is a 7. Next row are as it is, that is a 0, 1, minus 2, 0, 0, 1 into A inverse, and here is a R1 minus 2 times R2, 1 minus 1, 0, minus 2, 0, 1. R1 minus 2 times R2, that is 1, minus 2, that will become 4, and overall here you will get, sorry, here is a R1 means what? 1, 2 times R2 means what? Minus 2, 1 minus 2, you will get here minus 1. Next is a 0, this minus 2 and minus 1, that will become plus, that is a 0 plus 2, here is a 2, and last element will be as it is 0, because both of them are 0. Okay, now by the next operation, already here that is a A33 is 1 here, therefore by the operation, what is the operation? By R1 minus 7 times R3 and R2 plus 2 times R3, we get, here totally we get the identity matrix, and it is 1, 0, 0, 0, 1, 0, 0, 0, 1 into A inverse, and here is a R1 minus 7 times R3, that is minus 1, and minus 7 into minus 2, that is a minus plus 14. Overall, you will get minus 1 plus 14, here is a 13. Next is R1 minus, here is a, keep these two as it is, and last is a minus 7, 0 minus 7. Next is R2 plus 2 times R3. This is R2 plus 2 times R3, 1 minus 4. 1 minus 4 is a minus 3, minus 1, here is a minus 1, and 0 plus 2 into 1, here is a 2. Last is minus 2, 0, 1. Okay, now the inverse of the matrices. Identity into A inverse is A inverse, therefore A inverse is equals to, okay, 13, 2, minus 7, minus 3, minus 1, 2, minus 2, 0, 1. This is the A inverse. 13, 2, minus 7, minus 3, minus 1, 2, minus 2, 0, 1. This is the A inverse. Next example is, show that with usual notations that for any matrix, capital A is equals to Aij 3 by 3, A11 into A21 plus A12 into capital A22 plus A13 into capital A23, that's equals to 0. Let capital A is equals to Aij matrices 3 by 3, and here is a matrix A11, A12, A13, A21, A22, A23. Next is a A31, A32, A33. Okay. Now we'll calculate one by one. First is calculate the value of A21. Capital A21 is equals to minus 1 raised to 2 plus 1 M21. Okay, overall you will get minus 1, and here is a A12, A13. Next is A32, A33. Now solve this. That is a minus in bracket A12, A33 minus A13, A32. This is the value. If you operate the negative sign, then you will get minus A12, A33 plus A13, A32. This is the value of A21. Okay. Now the next is A22, A22, that is equals to minus 1 raised to 2 plus 2. Okay, and here is a M22. Okay, this equals to M22. Therefore here is a A11, A3. Next is a A31 and A33. Now their product, here is a A11, A33 minus A13, A31. Okay, this is the value of A22. Now next is A23, that is equals to minus 1 raised to 2 plus 3. Okay, M23, and overall you will get minus A23. Therefore here is a A11, A11. Next is A12. Okay, and the last is A31 and A32. And if you evaluate it, then you will get minus in bracket A11, A32 minus A12, A31. Okay, and operate the negative sign, then you will get minus A11, A32 plus A12, A31, and this is the value of A23. Okay, and in this way we have all the values. I will substitute here. What is here? A11 into A21, A12 into A22 plus A13 into A23. Substitute the values, then you will get here A11 into A21 plus A12 into A22 plus A13 into A23, and here you will get A11 in bracket A21, which is minus A12, A33, A13, A32. Therefore here is a minus A12. Next is a 33, A33 plus A13 32 plus A13 and A32. Okay. Next is A small a12 into capital A22. That is A11, A13. Here is A11 and next is A33 minus A13, A31 and the last is A13, A23. What is, sorry, A23, its value is minus A11, A32, A12 into A31 and overall it's a, now here is a product minus A11, A12, A33 plus A11, A13, A32 plus A11, A12, A33 minus A12, A13, A31 minus A11, A13, A32 and last is A13, A12, A31. Therefore, here is a minus A11, 12, 33 and here is a plus. These two plus and minus get cancelled. Next is A11, 13 and these two terms will get cancelled. And last is 12, 13, 31. 12, 13, 31. These two also get cancelled. And overall here you will get as a 0. Now the next is A11, that is equals to minus 1 raised to 1 plus 1. Here is a M11 and that is equals to M11 means what? Here is a A22, A23 and last is A32 and A33 and its evaluation is therefore the capital A12 that is equals to minus 1 raised to 1 plus 2 capital M12 and here is for all it will be the minus 821. Next is A23 and last is A31 and A33. Next we calculate capital A13 that is a minus 1 raised to 1 plus 3 here M13 and overall you will get here plus. Okay, therefore here is a A21, A22, A31, A32. Okay. Now we substitute the values. Therefore, here is a small a11, capital A11 plus small a12, capital A 1 2, small a 1 3, and capital A 1 3, and this equals to, that is equals to A 1 1, and here is the matrix A 1 1. What is it? A 2 2, A 2 3, A 3 2, A 3 3. Next is minus A 1 2. Okay, minus A 1 2. Then here you will get A 2 1, A 2 1. Next is A 2 3, A 3 1, A 3 3, and the last is A 1 3. Okay, A 1 3. Therefore, we get here here is A 2 1, A 2 2, A 3 1, A 3 2, and this is nothing but the determinant of the matrix. There is A 1 1, A 1 2, A 1 3, A 2 1, A 2 2, A 2 3, A 3 1, A 3 2, A 3 3. Okay, and this is equals to the determinant of the matrix. This is equals to the determinant of the matrix. Now the question number 20. If matrix A is equals to 1 0 1, 0 2 3, 1 2 1, matrix B is 1 2 3, 1 1 5, 2 4 7, then find a matrix capital X such that capital X A is equals to B. Okay. Now consider capital X into A is equals to B. Okay. Now here we will write here capital X into A matrix. What is A? A is 1 0 1, 0 2 3, 1 2 1, and on this side matrix B 1 2 3, 1 1 5, 2 4 7. Okay, therefore we will apply here the column transformation, and this is make this matrix as an identity matrix. Then we will get the matrix X. Okay, first this is 1, make this 0, it already 0, make this as a 0. Therefore by C3 minus C1 we get C3 minus C1 we get capital X 1 0 1 0 2 2. C3 minus C1, here is a 0 3 and 0. Okay, that is equals to 1 1 2 2 1 4. C3 minus C1, here is a 2. Okay, next is a 4, and last is 5. This is first one. Next is by the operation, make this element as a 1 by 1 upon 2 C2 capital X 1 0 1 0 1 1 0, 3, 0, and here you will have 1, 1, 2. Next is 1, 1 upon 2, and last is 2, 2, 4, 5. Okay. Now by the operation, make this element as a 0, that is a C3 minus, you will get here C3 minus 3 times C2. C3 minus 3 times C2, then y, and again we get. Okay. Therefore, these capital X, the first column is as it is, that is 1, 0, 1, 0, 1, 1, 0, 0, and here is a C3 minus 3 times C2, that is here you will get minus 3, and on this side first 1, 1, 2 as it is. Next is second will be as it is again, 1, 1 upon 2, and here is a 2. C3 minus 2 times C2. C3 minus 2 times C2. Therefore, here 2 minus 3 will get minus 1. Next is 4 minus 3 by 2. 4 minus 3 by 2. Therefore, you will get 5 by 2. 4 minus 3 by 2, you will get 5 by 2. And the last is 5 minus 2 into 3, that is 6. And overall, you will get minus 1. Okay. Now by the next operation, by minus 1 upon 3 C3, here you will get 1, 0, 1, 0, 1, 1. Next is 0, 0, 1, and here is a 1, 1, 2, 1, 1 upon 2, 2, and minus 1 upon 3 into minus 1. Therefore, here is a 1 upon 3. Next is minus 5 by 6. Minus 5 upon 6. And lastly is 1 upon 3. Now the next operation. By the operation C1 minus C3 by C1 minus C3 and C2 minus C3. Therefore, here you will get the identity, that is a 1, 0, 0, 0, 1, 0, 1. Therefore, here is a C1 minus C3. This is C1 minus C3. That is 1 minus 2 by 1 upon 3. It is a 2 upon 3. 1 minus minus will become plus. 1 plus 5 by 6. That is a 11 by 6. It is 11 by 6. And last is 2 minus 1 upon 3. That is a 5 by 3. Now the second column, C2 minus C3. That is 1 minus 1 by 3. Therefore, you will get 2 upon 3. Next is 1 by 2 minus 5 by 6. Multiplied by, here is a 3. 3 minus 5. That is a minus 2. Sorry, once again I will repeat here. 1 upon 2. Minus and minus will become plus. That is 1 upon 2 plus 5 by 6. Means what? 3 plus 5, 8. 8 upon 6, and that will become 4 upon 3. And what about the last 2? Minus 1 upon 3, that is a 5 by 3. And last is, here is a 1 by 3 as it is, minus 5 upon 6 and 1 upon 3. Okay, therefore here capital X equals to, now take the common as 1 by 6 and the matrix is, the first is 4, 4, here is a 2, next is 11, then 8, minus 5, and last is a 10, 10, and here is a 2. In this way, we have completed the total matrix chapter with both miscellaneous, that is the miscellaneous 2a and the 2b. Now we'll see in the next video. Till then, goodbye.